Tick marks on electrical floor plans represent the number of conductors within a conduit run between electrical devices. These markings, typically short lines, indicate the quantity of phase conductors, neutral conductors, and equipment grounding conductors required for each segment of the circuit. The question is whether electrical contractors actually use these tick marks, or if they independently determine the necessary conductors. There are several factors that influence the usefulness and reliability of tick marks. Firstly, the accuracy and completeness of the floor plans are critical. If the plans are outdated, incomplete, or contain errors, the tick marks may not accurately reflect the actual wiring requirements. Secondly, the complexity of the electrical system can affect the reliance on tick marks. In simple residential projects, the wiring is straightforward, and contractors may rely less on tick marks. However, in complex commercial or industrial projects with multiple circuits and intricate wiring configurations, tick marks can provide a valuable visual aid. Thirdly, the experience and expertise of the electrical contractor play a significant role. Experienced contractors may have a better understanding of electrical codes and wiring practices, allowing them to accurately determine the conductor requirements, even without relying heavily on tick marks. Fourthly, the local electrical codes and regulations must always be followed. The National Electrical Code, or NEC, provides specific guidelines for conductor sizing, conduit fill, and grounding requirements. Contractors must ensure that their installations comply with these codes, regardless of the tick mark shown on the floor plans. Fifthly, communication between the electrical engineer and the contractor is important. If there are any discrepancies or ambiguities in the floor plans, the contractor should communicate with the engineer to clarify the requirements. This can help prevent errors and ensure that the installation is done correctly. The typical electrical circuit consists of several conductors. A phase conductor carries electrical current from the source to the load. A neutral conductor returns the current from the load back to the source. An equipment grounding conductor provides a low impedance path for fault current to return to the source, helping to protect against electrical shock. In a typical 120-volt circuit, you will usually find one phase conductor, one neutral conductor, and one equipment grounding conductor. In a 208 volts or 240-volt circuit, you will usually find two phase conductors, one neutral conductor, and one equipment grounding conductor. In a 480-volt circuit, you will usually find three phase conductors and one equipment grounding conductor. In some cases, a neutral conductor may not be required, such as in a dedicated 480-volt motor circuit. The number of conductors required for a particular circuit depends on the load requirements and the wiring configuration. The NEC specifies the minimum conductor size based on the ampacity of the circuit. Ampacity refers to the current carrying capacity of a conductor. Conductors must be sized to handle the maximum current that they are expected to carry. The NEC provides tables that list the ampacity of different conductor sizes and types. For example, Table 310.16 in the NEC lists the allowable ampacities of insulated conductors rated up to 600 volts, based on the conductor temperature rating and the ambient temperature. When determining the number of conductors in a conduit, it is important to consider the conduit fill requirements. The NEC limits the maximum percentage of the conduit cross-sectional area that can be occupied by conductors. This is to ensure that there is adequate space for heat dissipation and to prevent damage to the conductors during installation. The conduit fill requirements vary depending on the type of conduit and the number of conductors. For example, for 3 or more conductors, the NEC generally allows a maximum conduit fill of 40%. This means that the total cross-sectional area of the conductors cannot exceed 40% of the cross-sectional area of the conduit. When running multiple circuits in the same conduit, it is important to identify each circuit properly. This can be done by using different colored conductors or by labeling the conductors with circuit numbers. Proper identification of circuits is essential for troubleshooting and maintenance purposes. It is also important to ensure that all connections are made properly and that the conductors are securely terminated. Loose connections can cause overheating and electrical failures. When pulling conductors through conduit, it is important to use a pulling lubricant to reduce friction. This can help prevent damage to the conductors and make the pulling process easier. The size of the conduit is also an important consideration. The conduit must be large enough to accommodate all of the conductors and to meet the conduit fill requirements of the NEC. The NEC specifies the minimum conduit size based on the number and size of the conductors. When selecting conduit, it is important to consider the environmental conditions. For example, if the conduit is exposed to moisture or corrosive substances, it should be made of a corrosion-resistant material. Common types of conduit include rigid metal conduit, intermediate metal conduit, electrical metallic tubing, and rigid polyvinyl chloride conduit. Each type of conduit has its own advantages and disadvantages in terms of cost, strength, and corrosion resistance. The installation of electrical wiring must be done in accordance with the NEC and all applicable local codes. It is important to hire a qualified electrical contractor to perform the work. A qualified contractor will have the knowledge and experience to ensure that the installation is done safely and correctly. Before starting any electrical work, it is important to obtain the necessary permits from the local building department. Permits are required for most electrical installations to ensure that the work meets the minimum safety standards. Electrical inspections are typically required after the installation is complete. The inspector will verify that the work was done in accordance with the NEC and the local codes. If any deficiencies are found, they must be corrected before the installation is approved. Working with electricity can be dangerous. It is important to take precautions to avoid electrical shock. Always disconnect the power before working on any electrical equipment. Use insulated tools and wear appropriate personal protective equipment. If you are not qualified to perform electrical work, hire a qualified contractor to do it for you. Electrical safety is paramount. Ignoring safety precautions can lead to serious injury or death. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrical contractor or engineer before undertaking any electrical work. The NEC is a comprehensive document that provides detailed requirements for electrical installation. It is updated every 3 years to reflect the latest technological advancements and safety standards. It is essential for electrical contractors and engineers to stay up to date on the latest version of the NEC. Continuing education courses and professional development programs can help to ensure that they have the knowledge and skills necessary to perform their work safely and effectively. In summary, tick marks on electrical floor plans can be a helpful tool for electrical contractors, but their usefulness depends on several factors, including the accuracy of the plans, the complexity of the system, and the experience of the contractor. Regardless of the tick marks, contractors must always comply with the NEC and all applicable local codes. Firstly, verify the accuracy of the floor plans and tick marks before starting any work. Secondly, consider the complexity of the electrical system when determining the reliance on tick marks. Thirdly, use your experience and expertise to determine the conductor requirements. Fourthly, always comply with the NEC and all applicable local codes. Fifthly, communicate with the electrical engineer if there are any discrepancies or ambiguities in the plans. By following these guidelines, electrical contractors can ensure that their installations are done safely and correctly.